All right, 7.2. We are solving systems of equations using elimination today. So elimination, we have to follow the steps to obtain coefficients for x or y that differ only in signs by multiplying all terms of one or both equations by suitably chosen constants. So, in other words, we need the same number but opposites for each variable. So if I have a 2x, I would need a negative 2x in order for them to cancel out. So our goal is to pick a variable and eliminate it to get it to cancel. And then we just use substitution after we solve for one variable, but plug it back in. So looking at example 1, we always want to think, do I have the same number but opposites here with either one of my variables? Which one? The y's. So we can just use elimination right off the bat and combine our like terms. So what's 3x plus 5x? 8x. What happens to the y's? Cancel. You get eliminated because it's the same number but opposites. And then 4 plus 8, 12. What would I do next? Divide by 8. So x is equal to 3 over 2 because we divide them both by 4. Simplify your fraction. Is that it? What do I need to find next? Y. So I have x. I'm going to plug it back in to solve for y. You can plug it into this x, or you could plug it into the x in the bottom and use the second equation to solve. It doesn't matter. I'm going to plug it into the first. I usually look and see which one looks easier. Sometimes they're just both equivalent. So again, it doesn't matter. If you do the math right, you'll get the same answer. What do I have to do first here? Multiply 3 over 2 by 3. How do I multiply fractions? Multiply straight across. This becomes 9 over 2 plus 2y is equal to 4. What would I do next? Subtract. So we subtract 9 over 2 on both sides. How do I add a whole number and a fraction, or subtract a whole number and a fraction? I put 4 over 1 and find a common denominator. Well, what would my common denominator be? 2. So I have to multiply the top and the bottom here by 2. So it becomes 8, bless you, 8 over 2. So we just subtract the numerators. What is 8 minus 9? Negative 1 over 2. What do I do next? Divide both sides by 2. What happens? What happens if I have a fraction and a fraction? Keep, change, flip. So this is 2 over 1. So we change to multiplication and flip it to 1 over 2. So this y is equal to negative 1/4. How would I write my answer? 3 over 2, comma, negative 1 over 4. So one way we could do it from here, I had 9 over 2 plus 2y is equal to 4. What's one way that we can get rid of fractions in our equation? Multiply everything by 2. So the fraction part cancels here, so I have 9 plus 4y is equal to 8. Then what can I do? Subtract 9. So I have 4y is equal to negative 1, and then what? Divide by 4. So y is equal to negative 1/4. So you could do it that way, you don't have to deal with fractions until the very end, which is probably easier. So if you can think about it while you're working it out, just multiply everything by a common denominator to get it to cancel. That way you don't have to work with fractions.
But if you're multiplying all of them, it's just like you multiply everything by the denominator.
Yes. Again, we want to solve by elimination, so I need the same variable, but opposites. Do I have that here? No. So what do I have to do to make them the same number, but opposites? Okay, I can do that. And which variable would I cancel out if I do that? The y's. So Tomas said we need to cancel out the y's. You could have picked the x's. It doesn't matter which one you do here. The order of what you do doesn't matter. Everybody's work might be different because they might do one thing versus another. So Tomas said multiply the first one by 4 and then the second equation by 3. He probably picked the y's because he already saw that they were opposites. That way we don't have to multiply by a negative. So my new first equation is 20x plus 12y is equal to 36. My new bottom equation is 6x minus 12y is equal to 42. Will my y's cancel out now? Yes, because I have a positive 12y and a negative 12. So they're the same number but opposite. So we can go ahead and combine everything together. So 20x plus 6x be 26x. 36 plus 42, 78. Divide both sides by 26. So x is equal to 3. Nice, a whole number. Am I done? What do I have to do next? Plug it in. What do you want to plug it into? We can plug it into the second one. So 2 times 3 minus 4y is equal to 14. Make sure you follow your order of operations. You got to multiply first. And then what should I do? Subtract the 6. So negative 4y is equal to 8. Divide by negative 4. So what does y equal? Negative 2. How would I write my answer? 3 comma negative 2. So when solving systems of equations, we can have exactly one solution, which is what our last two questions had. You can have infinitely many solutions, or we could have no solution. So on this page, it shows the graphs of what each one would look like. If we have infinitely many solutions, our two systems of equations end up being the same line. So infinitely many is when it's the same line. When you have parallel lines, the lines never touch, so this would be no solution. And then if they intersect at one point, this is where it would be one solution. And the solution is where your 2 points intersect. So we don't actually have to graph these. We can just work them out algebraically by elimination and see which A, B, or C matches our graph, 1, 2, or 3. So let's look at A. So we're solving with elimination. Do I have the same number but opposites here? No. But can I make one of them the same but opposites? Which one? I can multiply the top by 2. So my new top equation will be 4x minus 6y is equal to 6. So my x's cancel because they're the same number but opposites. What's negative 6y plus 6y? 0. So nothing left on the left side, just 0. And what's 6 plus 6? 12. Does 0 equal 12? No, so what's my answer here? No solution. So which graph would that match? The second one. All right, let's look at B. Do I have the same number but opposites here? No. So what do we need to do to make it the same? I can multiply which one? The second one by what? Negative 2. That'll get my x's to cancel. So if I multiply everything in the second equation by negative 2, I end up with negative 2x minus 4y is equal to negative 10. So now I'm going to combine my two equations together. My x's cancel. What's negative 3y minus 4y? Negative 7y. And 3 minus 10? Negative 7. Divide both sides by negative 7. So what does y equal? What does it equal? Positive 1. How would I solve for x? plug in y. I'm going to plug it into the second equation. So I have x plus 2 times 1 is equal to 5. So x plus 2 equals 5. Subtract 2. What does x equal? 3. How would I write my answer? 3, 1. So which graph would this match? The third one, because that's where we have one solution. And if you look at our graph, the two lines intersect at the point 3, 1. Now let's look at C. What could I do for C? Multiply the top by 2. So you get 4x minus 6y is equal to 6. The x's cancel. What's negative 6y plus 6y? 0. And 6 minus 6? 0. What happens when 0 is equal to 0? Infinitely many solutions. So C, it would match up with A, the first one here. Let's look at example 4. Again, solving with elimination, what do I need to do? Multiply the first equation by 2. So I get 2x minus 4y is equal to 6. X's cancel. What's negative 4y plus 4y? 0. 6 plus 1? 7. Does 0 equal 7? So what's my answer? No solution. All right, example 5. What should I do first? Awesome. Multiply the top by negative 2. So we get negative 4x plus 2y is equal to negative 2. So what happens to the x's? Cancel. 2y minus 2y, 0. Negative 2 plus 2, 0. What happens when 0 is equal to 0? Infinitely many solutions. Sure. So I have decimals. We don't really like working with decimals, just like we don't like working with fractions. So how can I get rid of the decimals? Awesome, I can multiply the top by negative 10. Perfect. So my new first equation becomes negative 31x plus 29y is equal to 95. Awesome. Multiply everything by 10. When you have decimals, you'll get rid of the decimals. What happens to the x's? Cancel. What's negative 12y plus 29y? 17y. And 41 plus 95? 136. Divide both sides by 17. Amazing. 8. Y equals 8. Still have to find x, so what would I do next? Plug it in. So I'm going to plug it into the second equation. That way I don't have to worry about the decimals in the first. So 31x minus 12 times 8 is equal to 41. 31x, what is negative 12 times 8? So negative 96 is equal to 41. Add 96 to both sides. $137. Divide both sides by 31. So what does x equal? I don't think anything goes into 31. So it'd just be 137 over 31. How would I write my answer? 137 over 31, comma 8. Always x, then y. You don't have to turn it into a decimal. Leave it as a fraction. That way it's exact. But if it can be simplified, simplify it. All right, let's look at the next. Again, we have fractions. How can I get rid of the fractions? Multiply by 6. Perfect. Because 6 will get rid of both the fractions here. If you wanted to, you can multiply everything by 2 and then multiply everything by 3 to get rid of both of them, but just do it all together and multiply everything by 6. So here, 2 cancels out with 2 from the 6, so I'm just multiplying this by 3. Is everybody with me with how I did that?
Because then, can't you just multiply them by 3?
Yeah. Well, the other one, this second one, 3 cancels out with 3 from the 6, so I'd be left with 2, so I'm multiplying this by 2. So we have to distribute. So this would be 3 times 2x, which is 6x plus 15. And then 2 times y, 2y minus 2 is equal to negative 4 times 6, negative 24. Let's combine our like terms here. I have to subtract 15 on both sides. Oops. And add 2. So we get 6x plus 2y is equal to negative 35. 37. All right, we're combining it with this equation. Do I have same coefficients but opposites? No. But can we make them same but opposites?
Why are you combining it with that?
Because this is the first equation. But I got rid of the fractions to go here. Because I multiplied everything. So this is still the first equation, just written nicer for us to work with. We got rid of the fractions. We put it in the order that we liked. So this is the new first equation. So I still have to combine it with the second one. What are we trying to eliminate? The y's. Awesome. So we can multiply everything in the first equation by 2. Another common mistake that people will make, they'll forget to multiply the constant by 2. Just if you multiply by a number, make sure you multiply it by everything in your equation. So this would be 4x minus 2y is equal to 42. So combine our like terms, we get 10x, the y's will cancel, and that is equal to, what? 5. Divide both sides by 10, so x is equal to 1/2. Am I done? Nope. What do I have to do next? Plug it in. I'm going to plug it into the second equation here. So I have 2x, so 2 times 1/2, minus y is equal to 21. What is 2 times 1/2? 1. 1 minus y is equal to 21. Subtract 1. So negative y is equal to 20. So y is equal to negative 20. You can divide both sides by negative 1 or multiply by negative 1 or just flip the sign. So y is equal to 20, negative 20. How would I write my answer? 1/2 negative 20. Awesome. All right, let's look at the last page. 2 cheeseburgers and 1 small order of French fries from a fast food restaurant contain a total of 970 calories. 3 cheeseburgers and 2 small orders of French fries contain a total of 1,640 calories. Find the caloric content of each item. So we can call cheeseburgers C and French fries F. How would I come up with a system of equations? So 2C plus F is equal to 970. Perfect. That's 1. Awesome. 3C plus 2F is equal to 1640. All right, let's solve with elimination. Perfect. We can multiply the top by -2. So this would be -4 times C minus 2F is equal to negative 1940. Combine our like terms now because the F's will cancel. So negative C is equal to negative 300. So what does C equal? 300. How can I find F now? Plug it in. So I'm going to plug it into the first. So I have 2 times 300 plus F is equal to 970. So 600 plus F equals 970. Subtract 600 on both sides. So what does F equal? 370. So French fries are 370 calories and a cheeseburger is 300 calories.